In this video, I'll talk about packet capturing. Packet capturing can be used by either legitimate users or malicious users for a variety of reasons, including the establishment of a network traffic baseline. So by capturing a large enough amount of traffic, we can establish what is normal in terms of network traffic patterns. We can also capture traffic and then use it to troubleshoot network performance issues, such as if we have a jabbering network card that's sending out excessive traffic, or if we're getting a lot of network broadcasts that we don't think should be on the network. We can check out the source. So we use packet capturing then to monitor network traffic. It can record traffic and save it to a file for later analysis, and in some cases, some packet capturing tools allow you to replace contents within fields, within headers of the packet or in the payload, and then send it back out on the network again. Now, when we're capturing network traffic, we're talking about capturing it whether it's on a wired network or wireless. There are numerous packet capturing tools available. Some are hardware-based, where we can use rule-based traffic classification. Also, the ability to send packets to a different interface is an option. The ability to drop packets that we aren't interested in. Now, that could also be useful for mitigating things like denial of service attacks. It might not be just that you're not interested in capturing or recording that traffic, but it's suspicious and you don't want to have any part of it. At the software level, there are numerous applications out there to capture network traffic and to perform analysis. Wireshark is one. In Unix and Linux environments, we can also use the TCP Dump command. Here in Wireshark, if I click the leftmost icon in the toolbar, I can choose from the list of interfaces which one I want to capture network traffic on. So I see in my second interface here, I've got a number of packets going through that interface. That's the one I want to capture traffic on. So I'll just go ahead and click Start. And when I do that, it starts capturing the network traffic. I can see the source, where it came from, the destination, where the traffic is going to, the protocol, and additional information. Now, when I'm happy with that, I can go ahead and I'll click the fourth button from the left in the toolbar to stop the capture. And as we stated, we could save this for later analysis. Now, if I select an individual packet in this listing, in the middle of the screen, I can see the hardware frame, in this case Ethernet 2, where I can see the source and destination hardware or MAC addresses, that's layer 2. Then I can see the IP header, the Internet Protocol header, where I see things like the time to live, the TTL, and as I scroll further down, the source and destination IP addresses, those are layer 3 addresses. Now let me just collapse the IP header. Then I see that this is a UDP transmission, user datagram protocol, and again I can see here the source and the destination port. So again, that's layer 4, and then I see data. Now the data is the payload, the actual contents of the packet. Everything else that we've just looked at is used to get the packet to where it's going and back. So in the data we have the payload. Essentially that would map, generally speaking, to layers 5, 6, and 7 in the OSI model, depending exactly on what's happening. So our frame here where we see our MAC addresses, layer 2, the IP header, layer 3, the UDP header, layer 4, and the payload or data in the packet, layers 5, 6, and 7 of the OSI model. So when you're capturing network traffic, we have to understand the distinction between hubs versus switches, because in a hub environment, all the devices plugged into the hub can see all of the traffic transmitted by all other devices plugged into that hub. Now with an Ethernet switch, it's different. Two communicating devices can see their own unicast transmissions to each other, but they don't see other unicast transmissions for other stations on the same switch. They will see broadcasts and multicasts, but that's about it. So if you're using a network switch, which pretty much everybody would be, then you have to think carefully about which physical port your devices plug into if you want to capture network traffic. Because if your switch supports it, you want to make sure you configure port mirroring, essentially so all network traffic in other ports is copied to the one where you're capturing traffic. Otherwise, if not, when you capture network traffic, you might only be seeing essentially any traffic related to your station. Again, other than broadcasts and multicasts. So the switch monitoring port then is very important. We should also consider the fact that if we're interested in capturing traffic going through a router, then maybe that's where we would run our packet capturing tool. A multi-home device is one that's got at least 2 network interfaces. So if we've got a server acting as some kind of a firewall, Then we might run our packet capturing software there to capture traffic entering or leaving the network, same as a router. We have to watch out for ARP cache poisoning. This is where a malicious user can update the MAC address in client ARP cache tables in memory with the rogue MAC address. In other words, with their MAC address for their fake router. Now, that can be used for good to redirect people through a more efficient router, or for evil, where a malicious user is really only interested in getting all the traffic funneled to one location so they can capture it all, even in a switched environment. When you capture network traffic, you can configure a capture filter so that you're filtering what you're capturing in the first place. Or you could capture everything that your machine can see on the network, and then you can configure a display filter to filter out what you're looking at. So, for example, if you only want to see SMTP mail traffic from a certain server, you can easily do that. So, for example, here we see in our first statement, we are filtering by an IP source address. The second example here, we can filter by a TCP port number equal to 25, which would be SMTP, or we might look for ICMP traffic. In the third example, we are taking a look at the first three portions of a hardware MAC address to ensure they match what's been filtered for here. Now, these are filter statements that we might use in a tool such as Wireshark. In this video, we discussed packet capturing.